Have you ever just thought about it? The idea of a machine that could run forever. You kickstart it once and it just goes. Limitless, free energy for all time. It's a fantasy that's as old as we are, a quest that's grabbed hold of inventors and dreamers for centuries. So today, let's go on that quest. Let's chase the impossible.
And I'm not kidding when I say this has captivated some of the greatest minds. We're talking about Leonardo da Vinci, way back in 1494. Even he was sketching out ideas. Of course, he eventually called the whole thing a vain chimera, basically telling people to go hang out with the alchemists trying to turn lead into gold. It just shows you how deep this obsession really runs.
But that dream never really died. And this question, which I pulled right from a Reddit discussion, gets to the absolute heart of it. We know, a true perpetual motion machine is impossible. But how close have we actually gotten? What's the next best thing? That's what we're going to dig into.
But before we can see how close we've come, we've got to meet the villain of our story. There's one big thing standing in the way of a machine that runs forever, and that's the fundamental laws of physics.
Okay, so right off the bat, we need to get one thing straight because this is a really important distinction. Perpetual motion itself? Totally possible. Think about a tiny particle, a neutrino, zipping through the pure emptiness of space. It's just going to keep on going, pretty much forever. But a perpetual motion machine? That's a whole different story. That's a device that's supposed to actually do work. Light up a city, turn a wheel, without ever needing a single drop of fuel. And that's where we slam right into a brick wall.
And the reason why comes down to this one single, really powerful word: entropy. It's just an unbreakable law of the universe that says energy always spreads out. It gets messy. Every single time a gear turns, a little puff of energy is lost as heat from friction. Every time a sound is made, energy escapes into the air. It's kind of like pouring cream into your coffee. The cream is always going to spread out and mix in, right? It will never ever spontaneously pull itself back together into a perfect little drop. That, in a nutshell, is entropy, and it's why these machines just can't exist.
But here's the thing, just because you can't create energy from nothing doesn't mean you can't get really clever. Some of the closest things we have to perpetual motion machines aren't self-powered at all. Nope, they're actually just brilliant little thieves, constantly stealing tiny sips of energy from the world around them.
And these are just perfect examples. Look at these amazing atmospheric clocks. You've got the Beverly clock, which has been ticking away since 1864, powered by daily temperature swings pushing on a little container of air. Then there's Cox's timepiece, all the way from the 1760s, using changes in air pressure. And maybe the most famous, the Atmos clock. It has a sealed chamber of gas that expands and contracts with just a 1-degree change in temperature. That little movement is all it needs to wind itself. They look like they run on magic, but really, they're just running on the weather.
So that's one approach. But on the flip side, you've got a totally different strategy. These are the efficiency champions. These devices don't steal energy. Instead, they're built to be so ridiculously efficient that they lose almost nothing, letting them run for hundreds of years on a single sealed-up power source.
And to give you an idea of what I mean by hundreds of years, I just want you to look at this number: 10 billion. That's the estimated number of times a tiny bell at the University of Oxford has rung. And get this, it's still going.
This incredible thing is the Oxford Electric Bell. It's been running since 1840 on a pair of early batteries called dry piles. A little metal ball swings back and forth between two bells, powered by static electricity. And each time it swings, it uses just an unbelievably tiny bit of charge. The wildest part? We don't even know for sure what's inside the batteries. They're sealed under a layer of sulfur, and if we open them, the experiment would be ruined. It's this amazing lesson in just how powerful extreme efficiency can be. So that's this incredible historical marvel, right? Well, it has a super cool modern cousin in the world of physics, one that takes this idea of not losing energy to its absolute theoretical limit. Let's talk about superconductors. Here's the deal. You take certain materials and you cool them way down to almost absolute zero. When you do that, their electrical resistance just vanishes. It's gone. So if you start a current flowing in a loop of this stuff, it just keeps going and going, with pretty much zero energy loss. In actual experiments, scientists have had these currents running for more than 28 years. It's one of the closest things we've ever made to a perfect, self-sustaining loop of energy. Okay, So we've seen clever energy thieves, and we've seen these incredible efficiency champions. But what happens when you combine those ideas and you decide to think bigger? I mean, way bigger. What happens when you try to engineer something not for a few centuries, but for millennia?
And that brings us to this mind-bending number, 10,000 years. We're not talking about a little bell in a lab anymore. We're talking about a statement, a monument to humanity's place in time.
This is the vision behind the clock of the long now. It's this monumental mechanical clock that's being built right now deep inside a mountain in Texas. And it's being designed to do one thing: keep accurate time for the next 10 millennia. It's meant to force us to think on a totally different timescale.
And the principles behind it are just genius. It's made from super durable stuff, obviously. It's designed so that it can be maintained with simple Bronze Age technology. But the best part? Its power source. It's a clever thief, just like those little atmospheric clocks. It uses the temperature difference between the hot Texas day and the cool night to harvest just enough energy to keep itself wound and to keep it synchronized with the sun.
Now, if engineering something for 10,000 years sounds futuristic, well, brace yourself, because there's a new technology on the horizon that thinks on that same timescale, but with a wild twist. It turns nuclear waste into a power source that could last for thousands of years. They're called diamond batteries. Scientists take carbon-14, which is a waste product from nuclear reactors, and they encase it inside a tiny man-made diamond. As that carbon-14 naturally decays over thousands of years, it releases electrons, which creates a small but incredibly steady electrical current. And since carbon-14's half-life is almost 6,000 years, these batteries could power things like sensors or pacemakers or deep space probes for a time span that just blows away anything we have today.
All of this stuff, the old clocks, the hyper-efficient bell, the 10,000-year monument, it all seems to circle back to this one really profound question. It's a question posed by the creators of that long now clock. Are we being good ancestors?
And that's really where I want to leave you. The quest for true perpetual motion might be impossible, but that pursuit has led us down these incredible paths, forcing us to build things that defy our normal sense of time. So the final question isn't really about a machine, it's about us. If we can design a clock to last for 10 millennia, what else should we be building? What ideas, what knowledge, what values to last just as long? What is our real legacy going to be?